Okay, so now we do a short revision for your chapter 3 to increase your answering technique lah. So first one, normally for chapter 3 when came out essay, you always ask you what is the definition for the empirical formula. So you can write this it's a chemical formula, show the simplest ratio of the atom of each element in the compound. So for the experiment, for method number 1, right, is originally for magnesium that burn with oxygen to form magnesium oxide. Okay, so you can write the first method is magnesium oxide lah. So why do we choose this method? Because magnesium is a very reactive metal. Magnesium is a reactive metal that you will easily react oxygen to form magnesium oxide. So the reason we chosen this method is because of magnesium is more reactive metal. Then for the second one is using for this one, the second method, we actually use for copper 2 oxide. Okay, why copper 2 oxide? Because if you use copper, you burn with oxygen, right? The reaction occur, but will be very, very slow. Very slow. Because for the copper is the less reactive metal. They don't react with oxygen fast. They will do it very slow. So we don't use the first method for this. So we chosen the second method. Why I chosen the second method? Because copper is less reactive than the hydrogen. So the oxygen will be taken away by the hydrogen. So it becomes H2O. Okay, so the reason you can write, because copper is less reactive than with oxygen, less reactive than hydrogen. So why we don't choose? Because copper is less reactive than oxygen, so the reaction very slow. So we chosen the second method because copper is less reactive than hydrogen, so that your hydrogen are able to remove the oxygen from the metal oxide to form metal Y and water lah. Okay, write the chemical equation between the hydrochloric acid and zinc. So you can write down the equation. The hydrochloric acid is HCl, zinc is Zn, and then because Zn is 2 plus, Cl is minus, so it becomes ZnCl2. Then hydrogen, nobody want come out as H2. Then the 2. Then after that, this is the equation. Then calculate the mass of the zinc required to produce 100 cm³ of the gas. So first, you have to convert the cm³ into dm³. Then use the number of mole of hydrogen equals to volume, 1 molar volume. So volume is 0.2, molar volume is 24, you get this mole. Then from the equation, let's say from this equation, you realize that zinc and the hydrogen gas the ratio is 1:1. So 1 mole of hydrogen gas produced by 1 mole of zinc. So 0.00417 produced by 0.047. So after that, from there, you start to able to know the zinc is 0.0417 times the molar mass of the zinc is 65. Then you get this number lah. Then move on to here. This one is a hydrocarbon. So whenever I tell you hydrocarbon, carbon is C, hydrogen is H. So hydrocarbon is C and H. Then after that, they give you a percentage. So when they give you a percentage, you assume the sample is 100 gram. Why? 100 gram equals to 100%. Then after that, you just put the percentage of this percentage in. So 100 gram equals 100%. 85.7% means 85.7 gram. Then divide by molar mass. For carbon is 12, hydrogen is 1. You divide. After divide, take the smaller one. Take the smaller one, both divide by the smaller number. So both divide by the 7.1425. You get the ratio 1 is 1, 1 is 2. Okay. Then from there, the empirical formula will be C1H2. So CH2. Then from empirical change to molecular, you just bracket M because you don't know the actual number is how much. So you bracket M. And then we know that the actual mass, the relative molecular mass is 56. So I put in my real formula because this is my real formula. This is my real mass. So I put them together. So carbon is 12, hydrogen is 2. I substitute in. I will get 14N equals to 56. So N will equals to 4. Then put this 4 back to here. You'll get the actual formula will be C4H8. Hydrocarbon can burn with completely in oxygen. So now we try to write out this equation. C4H8 plus O2, it becomes CO2 plus H2O. Okay, so carbon is 4, then 4 carbon, 8 hydrogen, 4 times 2. So total here got 8 oxygen and 4 oxygen. Add up together is 12. So put 6 times 2 is equal to 12. Yep, so this is the equation. After that, they want information for qualitatively and quantitatively. Okay, what is qualitatively then? Qualitatively is tell me who is the reactant, who is the product. So the reactant are hydrocarbon P, which is C4H8, then with oxygen gas. Then after the product is carbon dioxide gas and the water. So this is your reactant, this is your product. Okay, this is qualitatively. Here you don't need to mention the solid, liquid, gas, or aqueous because in your equation does not have the information. Then after that, quantitative means how much is the number. The number we have is the 1644. So you write 1 mole, write 6 mole, produce 4 mole and 4 mole of water. Then move on to the similar question that we have this X and Y. What is meaning by empirical formula and molecular formula? So empirical formula just told you just now. So a molecular formula will be the chemical formula show the actual number. This shows the simplest ratio. This one gives the actual number of each element in the compound. So for empirical formula for X can determine for experiment Y can name the X and Y. So as I told you before, this is the X should be your Mg. So become MgO to here to here. Okay, this is your copper burned with hydrogen gas because hydrogen is more reactive. Yeah. So the sample, you can just give anything, but I prefer to default write magnesium and copper lah, if possible. Okay, because it will be safer to handle those unknown. Okay, so just explain the difference by choosing this method so you can start to explain it. Yeah. So in your X, right, magnesium is more reactive while the Y is less reactive than hydrogen. Then another differences is for the X, right, they react to form X oxide, means the magnesium oxide. Then for Y oxide, they react with hydrogen to form back your metal Y and your water. So these are the differences. Okay, then they have 3 things here that 40% carbon, this and this. So the molar mass is 180, similar to the first question. So first, assume 100 gram of sample, 20 percentage. So hydrogen is 1, carbon is 12, 16. So put in the molar mass to divide. So carbon is 12, divide by 12. Hydrogen is 1, divide by 1. Then oxygen is 16, divide by 16. Okay, then after that you will see which number is the smallest. So the smallest number is this, so all divide by the smaller number. So 3.33, you get the ratio is 1 to 1. So from the formula you're able to get the empirical formula is C1H2O. So CH2O. So the molecular formula will be CH2O bracket N. The actual mass, the relative molecular mass is 180. So technically you can write relative molecular mass because molar mass and relative molecular mass, they are actually same number. So molar mass is got unit 180 gram per mole, but relative molecular mass is just 180. There's no unit. Because relative is how many times heavier. So don't have any unit inside. Then after that, you can put the real formula. So the real formula is this. Put equals to 180. So C is 12, hydrogen is 1, then oxygen is 16. Then you're able to get N equals 6. Put in the N equals 6 inside here. So put here 6, then you get C6H12O6. Then for this equation, okay, this equation is slightly a bit out of syllabus because it related to chapter 6. Okay, but anyway, you look at the answer. Okay, so this is the copper 2 nitrate. So in chapter 6, you learn that CuO, NO2, NO2. So for this CuO in chapter 3, we got learn before it's black color. So it's black solid its form. Because oxygen gas, a glowing reverse splitter is related because the glowing reverse splitter is to test oxygen gas. Then for the NO2 is a brown color gas. This one we will learn in chapter 6. Then they ask for the equation. Okay, then we refer to this one. Okay, this is another question there. What is relative atomic mass? So relative atomic mass actually is to get how many times heavier that the average mass of an atom compared with 1 over 12 of carbon 12. So carbon 12 is the one that we use as the standard atom lah. Why we chosen here? We can just choose any reason because carbon is a solid state, so easy to measure the original mass. Then they give you this equation. Okay, look at this equation. The same. They want the qualitative and quantitative. So in here, there has a solid liquid gas. So you have to mention that nitric acid, aqueous nitric acid, react with zinc oxide, solid. Then zinc nitrate solution, aqueous-based solution, and water liquid is the product. Then quantitative, then you can mention about 2 mole nitric acid react with 1 mole zinc oxide, produce 1 mole of zinc nitrate and 1 mole of water. So this is the figure covered in your first step exam. Then this is another one. Why carbon 12 are chosen to estimate as the standard? First, it is solid. You can choose any reason here. Easily handle because solid can measure easily, not like gas. Then carbon are combined with many other elements. Then in our world, there's a lot of things that consist of carbon. Okay, easily found. Then carbon 12 is a majority isotope because you know isotope we got carbon 12, 13, 14, but carbon 12 alone is 99%. So it's like very a lot lah. A lot means very accurate is 12, not 13 or 14 lah. Then after that, the relative atomic mass of carbon actually is 12. So it's 12. So it's quite simple. So look at this one. J, can you see 1, 2, 3, 4, 5, 6, 7? So it equals to 7, 1 over 12. So the relative atomic mass will equals to 7. That's J burned with oxygen to become J2O. So you see J burned with oxygen become J2O. So we balance the equation 2O, 2O, then 4J. Okay, use the relative mass, the answer for your B, calculate the mass of J needed to produce 0.2 mole. So if you refer to O2 and J, right, the ratio is 1 O2, 1 mole O2 react with 4 mole J. So now they have 0.2 mole of J oxygen gas. So 0.2 mole will react with 0.8 mole. Then put in 0.8 mole, put in the molar mass of the J is 7, you'll get 5.6 gram. Then what is represented by the symbol by Na? Who is Na? With the Avogadro constant, which is 6.02 times 10 power 23. What is the relationship between number of mole? So number of mole equals the number of particle over Avogadro constants. So they give you a formula here. So you can see this formula is actually ammonia. And then they ask what is the volume for 0.01 mole of this gas. So you can write now number of mole of ammonia gas equals to volume over molar volume. Molar volume is 24. You get the volume equals to 0.24. But because they want is cm cube, so 1 dm cube equals to 1000 cm cube. So 0.24 dm cube equals to times 1000, you get 240 cm cube. How many molecules are there? So you can just put in number of mole equals to number of particle over constants. So 0.01 mole, our constant is 6.02 times 10 power 23. You get 6.02 times 10 power 22. So pentane burn complete with oxygen to form a gas. So you check here. Pentane C5H12 burned completely with oxygen O2. It becomes your carbon dioxide gas plus water. Okay, so 5 carbon, 12 hydrogen, then 10 oxygen here, 6 oxygen, 16. So I put 8 here. Okay, that's all. Then move on to the next question. What is really the molecular formula? Similar to the previous answer. Relative molecular mass of Y is 88. So they want you to determine the molecular formula. So in this case, right, they really give you that is empirical formula equals to this. So you can write empirical formula equals to C2H4O4. Molecular formula, just add a bracket N. Then the mass equals to 88. Same with the previous question. Just put in the carbon is 12, hydrogen is 1, then oxygen is 16. You'll get N. Then 44 N equals to 88. So N equals to 2. Put in the N equals to 2 back to here. You'll get 2. Then times 2. 2 times 2, 4. 2 times 4 is 8. 2 times 1 is 2. It is. How did the middle reaction is complete? So remember, you have to write this down. Always ask this question. You need to repeat the process of heating, cooling, weighing process. It's performed several times until a constant mass is obtained. You need to open up a bit during the experiment to allow oxygen to enter to rare magnesium, because if you fully close, the purpose with fully closed is not allowing the magnesium oxide white film to fly out. But if you fully close, there's no oxygen. So what you need to do, you allow some oxygen to enter so that can react. So the chemical equation is Mg plus O2 become MgO lah. Then we move on to the next question. What is the empirical formula? Same question. Okay, empirical formula for the space here, you check here. Okay, the empirical formula, C6H12O6, if I simplify all divided by 6, I will get 1 to 1. Okay, compare and contrast these two formula. So if you look at these two, this and this. Okay, this is a very popular essay question. Compare and contrast these and tell me the similarity and the differences. So what is the similarity? Both have carbon, hydrogen, oxygen. So the differences is, for the first one, the ratio is for this, right, if you simplify, C2H4O2. So the ratio is 4 to 4. Then for the this will be 1 to 1. Okay, this is the differences. Then after that, the molecular formula show the actual number, then the empirical formula show the simplest ratio. Okay, so these are all the potential similarity and differences you can write. If WSC write with the so that understand what is the chemical equation. Okay, for this I explain to you lah, because this one is negative plus minus. So in this case, right, the Na here will replace the H plus here. So it becomes CH3, COO, Na. Okay, then the H and OH will become water. Okay, then after that, same percentage, put in the percentage, divide by the molar mass. Who is the smallest? This is the smallest. Both divide the smallest, you'll get 1 to 2. This is another question, empirical formula. The empirical formula of glucose is same. Qualitative, quantitative. Qualitative, so you just measure the reactants are glucose and oxygen. Then the product is carbon dioxide gas and water. No need to mention solid liquid gas, because in this equation there's no information, because they want you based on this equation, what is the information you can get. Then finally want to diversify. Oh, this one is the chapter is a chapter 4 form 5. So you just it's a question couple from trial, so you just ignore this question. Okay, what is the element found here? So you can see here, this is the element found. So you put in, we got carbon, oxygen, and hydrogen. Then you have to calculate 1, 2, 3, 4. So C4, H 1, 2, 3, 4, 5. H6, 1, 2, 3, 4, 5, 6. 6 only. Okay. So in the caking process, in the cake making process, when the cake batter is heated, then the baking powder decompose to form this. So to write now, baking powder NaHCO3 decompose to form sodium carbonate. So sodium is Na plus, carbonate is CO3, 2 minus, you get Na2CO3 plus carbon dioxide gas plus water. Okay, now with that balance equation, 2Na, go to here. Okay, then after that, hydrogen is balanced today. Carbon dioxide, yeah, is balanced today. Then after that, for mass occurring powder, if you have 0.03 gram of carbon dioxide, okay, so refer to the ratio. This what they want, baking powder is this. So ratio is 1 to 2. Okay, 1 to 2. So 0.03 should have 0.06 because 1 produce 2. So 0.03 becomes 0.06. So times 2. Okay, divide by 1 times 2, the ratio. Then after you get this already, you put in the 0.02, then put in the mass of Na is 23. Then after that, hydrogen is 1, carbon is 12, then oxygen is 16. From there, you'll get the mass equals to 5.04 gram. Then after that, this one, what is the purpose of lime water? To detect the presence of carbon dioxide gas. If got carbon dioxide gas, it will turn cloudy. Write the chemical equation. So you try to write out. Zinc carbonate. If you heat, right, it becomes zinc oxide plus carbon dioxide gas. For this related to chapter 6 form 4. Okay, so normally for if you come taking this for the first term exam for form 4, right, they'll usually will tell you that zinc carbonate heated will become zinc oxide and carbon dioxide. Okay, so they'll tell you. So qualitative, you can mention 1 mole of zinc carbonate decomposed to form 1 mole of zinc oxide and 1 mole of carbon dioxide. So what is the volume of the thing when 0.0125 of zinc carbonate is heated strongly? So zinc carbonate is this. So we look at the ratio between this and the gas release is this. So ratio is 1 to 1. So 1 mole zinc carbonate produce 1 mole carbon dioxide. 0.025 will produce 0.025 of carbon dioxide. So take the 0.025 carbon dioxide, find volume, use volume over molar volume, then you'll get equals to 0.6 dm3. Okay, then what is empirical formula? So the formula we check here, 1, 2, 3, 4, 5, 6, C6, 1, 2, 3, 4, 5, 6, H6. So empirical formula will be CH lah. Then this is the equation, the C6H6 react with chlorine will form this. So now they ask you 1.5 mole of the hydrochloric acid. How much is the volume of benzene needed? So the ratio between these is to 1 to 1. So you need to mention 1 HCl produced by 1 mole C6H6. So therefore, 1.5, you'll get 1.5. Okay, I want volume. So use volume over molar volume. Put in the 1.5, then we increase 1.5 times 24 equals to 36 dm3. Okay, if chlorine replace the bromine, so if this one change to bromine, so your equation actually exactly same. So change this to this only. Cl change to Br. Okay, the rest will be the same. Okay, now after that, move on to this. See, you can keep repeating, ask you molecular or empirical formula. So this is the molecular formula. So name compound X. Let's check. Produce compound X. So this one got an arrow here. So the compound X will be the glucose, C6H12O6, compound X. So qualitative information you can get. So first, based on this equation, so the reactant is water and carbon dioxide. The product is the glucose and oxygen gas. So the quantitative will be 6 mole. You write with 3 mole, 6 carbon dioxide, produce 1 mole water, glucose and 6 mole oxygen gas. But calculate the volume that carbon dioxide gas produced when 1 mole X. So you see the ratio between this and carbon dioxide is 1 to 6. So you mentioned 1 mole glucose produced by 6 mole carbon dioxide. So now I got carbon dioxide is 6 mole, then times the volume is 24 will be 144 dm3. Okay, then after that, so what is empirical formula? You check the calculator. 1, 2, 3, 4, 5, 6. C6, 1, 2, 3, 4, 5, 6. Okay, 6, O2, and 1 N. Okay, so the empirical, the molecular formula is C6H6 NO2. One information you can get, you can mention the first, it consists of carbon, hydrogen, nitrogen, oxygen, and then 6 carbon, 6 hydrogen, 1 nitrogen, and 2 atoms, oxygen atom. Then, okay, you can see here, this is considered slightly key, but he said that zinc decompose becomes zinc oxide, nitrogen dioxide, and oxygen gas. Then they say, ask you what is the mass of zinc nitrate is used. You can see starting, ending. So you minus off, you will get use up 9.45. Then balance equation, zinc nitrate. Then they could mention after heat, it produce zinc oxide plus NO2 plus O2. Okay, then we balance equation that 2N, 2N. But you can't balance oxygen because 3 times 6, 3 times 2 is 6. Here got 1, here got 2 times 2, 4, then here got 2, total 7. 6 and 7 is not balanced. Then in this case, you start because all got oxygen, you can't do anything. So I told you before, when start, you find the longest one times 2. This is the longest one times 2. But if you times 2, you have to rebalance everything. I put a 2 here, so 2 is the N, 2 is the N. Okay, after that, N times 2 is 4N. So 3 times 2 is 6, 6 times 2 is 12 oxygen. Here got 2 oxygen, 4 times 2 is 8 oxygen. Here got 2, so total 12. So equation is balanced. Mass of the nitrogen dioxide. Okay, first thing, since I know zinc nitrate, we use up this much. We must convert to mole first. Okay, so 9.45, then zinc is 65. So bracket 2, I put a 2 bracket here. After that, N is 14. Then oxygen is 16. So I'll get 0.05 mole. So based on the ratio, this and this ratio is 2 to 4. So you write down the equation. 2 mole produce 4 mole. So now I got 0.05 times 2. Divide by 2 times 4. You get this number. Okay. Then you'll get, convert them into the 0.01, sorry, so 0.1 times this number, it equals to mass 4.6. Okay, what is mean by chemical formula? Chemical formula show the actual number of each element in the compound. So actually, chemical formula are same with molecular formula, the what we call the definition. Okay, so the chemical formula for hydrogen gas is H2. Two information they can get. First, X oxide react with hydrogen to produce X atom and water molecule. Another information, 1 mole X oxide react with 1 mole H2 become 1 mole X and 1 mole water. So the formula mass for the X is AT, calculate the reactive mass. So because this is XO equals AT, you can see here is XO. We know O is 16. So then we will know X is 64. And okay, so this is the empirical formula. This is the molecular formula. Ratio will become empirical formula. So these are, they'll ask you the what is the definition, also chemical formula that show the actual number. Then they want you to compare. Okay, so what is the similarity? First, both consist carbon and hydrogen. Okay, both that it has hydrogen and carbon. So the simplest ratio for both are simplest ratio, both are 1 to 1. Okay, differences. The differences is here. So for the carbon and hydrogen, for the molecular formula is more than the empirical formula. Then reactive mass of this one is greater because the reactive mass. Then each benzene consists of 6 carbon, 6 hydrogen, but empirical formula only got 1 carbon and 1 hydrogen. So you can just write any potential difference between both of them. Then we refer back to this diagram. Who is X, who is Y? So similar to the first question we did. For X will be magnesium, then copper oxide. So you see for method 1 is Mg plus O2 become MgO. The method 2 is CuO plus H2 become Cu plus H2. Okay, so they want you to compare that. So both involve heating. You can see from the diagram, both got heating. Second one, one is more reactive to oxygen, one is less reactive than hydrogen, the differences. So one involve heat X and oxygen gas, one involve heat hydrogen with the metal oxide X. Can just give any differences also potential. Then the mass we check here. Okay, to get the mass, right, this is crucible. Crucibles plus X. Then this is the crucible plus X plus oxide. Okay, in order to get the X, right, you take this one minus this one because you cancel off, you get a metal X off. Then to get an O, right, you take this one by this one because cancel, you get oxygen. Okay, then after that, both divide. Lah. So X is 24. You get the ratio is 1 to 1. Okay, for this metal M burn with oxygen. So technically very obvious, this is Mg plus O2 become MgO. Then hydrogen gas pass through hot G oxide. The G oxide actually is CuO plus H2. Then it becomes Cu plus H2O. Okay. Then after that, example. So what is magnesium? Reason because it is more reactive than the oxygen. Then they ask you to draw the apparatus setup. So when carry out the experiments, it said, well, how to ensure it's react complete. So heating, cooling, weighing process is repeated until a constant mass is obtained. Then hydrogen gas passed through 1.6 cube. Then the 1.28 gram of G is formed. So you can put it here. 1.2 G, 1.28 G. That is G oxide, so you minus to get your oxygen. Then G, the mass is 64. Yeah, that's another is 16. You divide. The ratio is 1 to 1. So the chemical formula will be the GO plus H2. It becomes G plus H2O. In exam, if you're not sure, just write down the formula for the copper. See, copper is the same equation. You just convert the Cu to become G. Okay. Here you can write copper because he didn't ask you to guess who is G. So you have to write GO plus H2 become G plus H2O. Two safety precautions. First, need to flow through the hydrogen gas a few minutes before heating this one to remove all the air. If not, explosion occur. So the hydrogen gas must continue throughout the experiment. Okay, for the last question here, you need to calculate percentage. Okay, how do you calculate percentage? Okay, in your here, NH4, N2, they have 2N. Okay, 2N. So 2N divided by total mass. So you see 2 times 14. N is 14. 4 hydrogen. 14. 3 oxygen times 100%. You get 35%. Do the same thing for your urea. Whichever have higher percentage of the nitrogen is the better fertilizer. Because imagine now I buy 100 kg of the fertilizer. So the purpose of the fertilizer is because of nitrogen. Because for plant they are unable to absorb nitrogen directly from the atmosphere. So need the fertilizer. So 100 kg got 46 kg is nitrogen. This one 35 kg. Of course, the urea is the better one.